Hello, and welcome back to another video. Today I'm going to be talking about the Taylor series, which I'm pretty sure most of you must have already heard of or maybe even used in your maths or physics problems. Well, you must have come across series like this one, or maybe even the general form of the Taylor series, this one. But do you people know how to derive the relation, and using this relation, how to derive these series? Well, that's what I'm going to be talking about today, how to derive the Taylor series. Well, let us say that you want to find the value of sine of 1 radian or natural log of 2, and there's no particular method on how to find it. For this, you might take it as x is equal to ln 2, and so 2 is equal to e to the power x, and e is approximately 2.7. So you give an approximate values of x like 0.8, 0.5, 0.6 and try to approximate it, but that's very messy maths. And for sine of 1 degree also, it's super hard to find this in a easy way. At least you can perhaps draw a right angle triangle and find the ratio, but let us say that you have this, that you need to find, like you have this x square minus 5x plus 6, and you want to find f of 1. That's pretty simple. 1 minus 5 plus 6, which is 2. Or maybe even to an extreme case, you have f of x is equal to x square minus root 2x plus what value can I give over here, plus pi. And you want to find f of, let's say, e. Well, that's basically e square minus root 2e plus pi. The worst thing which can happen over here is multiplication of two complicated decimals. Well, root 2 is approximately 1.414 and this is approximately 2.71, and this is possible to do by hand, and it won't take more than maximum 2 minutes. E square is basically the same thing, 2.71 into 2.71. Pi is approximately 3.14. So this value is pretty easy to find out compared to natural log of 2 or sine of 1 radian. So, well, what if, so the Taylor series idea is that we can convert any function into polynomials to a certain extent. Well, let me show you how. Let's say you have the sine graph. Well, if you want to find out the value of sine in this region, you can find a polynomial like such as this one, which will approximate the value to a very accurate degree. Or maybe if you find a this is like a 2-degree polynomial, if you find a 3-degree, you might even have it like this. So this gives a better range of finding the values. Okay, so how do we do that? Well, okay, so let's see how to do that. Well, we can just take sine of x is equal to a naught plus a1x plus a2x plus an x to the power n. Well, we can take n tends to infinity, but I don't think that's necessary. We'll just try to find a of n, so we can write it in terms of a summation. Okay, so now this is the general form of a polynomial of degree n. So well, and let's say that this is true for all x's. So put x is equal to 0, so we get 0 is equal to a0. Okay, now so we have sine of x is equal to a1x plus a2x square plus an x to the power n. Now we need to find the value of a1. Okay, so how to do that? Well, we can't put x is equal to 0 or x is equal to, well, we need to isolate a1 to such that we can get a1 and like cancel out all the other a's. Well, we can, the one trick we can do is we can, well, cause all of this is polynomial, if we differentiate this will get to a power of 1 less than the degree it already is, and 1 less than 1 makes it a 0 degree polynomial, make this a 0 degree expression, and these all will have degrees of more than 0. So cos x is equal to a1 plus 2a2 plus 2a2x plus n an x n minus 1. And now we can, now we can put x is equal to 0. So we get a1 is equal to 1. And now same idea, differentiate again, so we get minus sine of x is equal to 2a2, nothing over here, 2a2 and n into n minus 1 an x to the n minus 2, and put x is equal to 0, so you get a2 is equal to 0. And like that, if you do it, you get minus cos x is equal to, well, this was 2a2 and over here it was 3a3x square, this became 6a3x, and over here 6a3, so you get a3 is equal to minus 1 by 6. So let's take up till here, sine of x is equal to x, okay, then there's no quadratic term, minus x cubed by 6, and there are other factors also, but we're taking for x is very small, like I showed in the graph, that this is not going to work for all x's because, well, it just won't, like I showed you in the graph. So, and if you take x is like x really small, like 0.1 or 0.1, then x to the power 5 will be super small that it can be neglected. Anyways, now this is basically the graph of sine x, and at x is equal to 0, I'll just take a different color, green works fine. So at x is equal to 0, they match up. At x is equal to 1, where sine x is approximately over here, so we can, this is approximately x is equal to 1. So over here this is 1 minus 1 by 6, which is 5 by 6. So this is not terribly off for x is equal to 1. Well, what is sine of 1? We can try to approximate it. 1 radian is approximately 60 degrees, so sine of 1 radian is approximately 0.8, which is 1.7 divided by 2. 1.7 is root 3, sine of 60 is root 3 by 2. 1.7 divided by 2, which is 0.85. And this value is 5 into 0.16, which is 0.8. It's pretty close, but it's a bit smaller, so yeah. Okay, I'm not sure of the intersections, but this is approximately how it's going to look. And maybe if you add a few more terms, you're going to get it much more closer than it is right now. Okay, so now let me try to derive a general form of this equation. So let's say that you have f of x is equal to a naught plus a1x plus a2x plus a3x cube plus, okay, so now we have a naught is equal to f of 0. Okay, and then this is, I'm just going to keep this over here right now. Then we have f prime of 0 is equal to a1. Okay, and now let me just try to find out f of x is equal to something and a n x to the power n. Now we need to isolate this term. So let's differentiate, let's find the derivative of it n times, and each time n goes down it loses 1 degree. So first time it comes down it is n, then n minus 1, then n minus 2, and finally it becomes a constant term, so into 2 into 1 a n. And you might notice that this is n factorial, so we can write a n is equal to f n 0 divided by n factorial. Well, it's 0 because of all the other terms behind it. So we can write in terms of Taylor series f of x is equal to sigma f of n 0 divided by n factorial from n n is equal to 0 to infinity. And now using this we can derive a lot of cool things. Okay, so let us take sine of x. So for sine of x we can see that a of 0 is equal to 0. Well, I've already done in the starting, so I'll quickly write these for initial steps, initial values. A of 2 is equal to 0, and well, you can see that a of, I'll just quickly write the derivatives of sine of x. So well, this is the first value, this is the initial f of x. F prime of x is cos x minus sine x and minus cos x and back to sine x. So it has a cyclicity of 4. So after every 4 steps it repeats, and you can see that sine of 0 and minus sine of 0 both are 0, and even this one will be 0, so all the even terms are going to be 0. So we only need to look at odd terms. Now odd terms, well, this one will be 1, this one will be minus 1, and if you come back over here, this term is going to be 1. So a of 3 is equal to minus 1. So you can write it like this, that sine of x is equal to 1 divided by 1 factorial into x minus 1 divided by 3 factorial into x cube plus 1 divided by 5 factorial x to the power 5. And if you want a closed form solution of that, so you can write like x to the power 2n minus 1 divided by 2n minus 1 whole factorial from n is equal to 1 to infinity. And forgot about the negative, minus n minus 1. So this is sine x. Okay, now for another cool one. Well, cos x is pretty elementary, so I'm not going to do that right now. I'll show for, well, I would have done for natural log of x, but for that it would be a bit tricky because natural log of 0 is, it tends to minus infinity. So that's why most people write the Taylor series in the form natural log of 1 plus x, because like that ln 1 or f of 0 tends to 0, and that's pretty defined. So let's see. So for ln 1 plus x, f of 0 is equal to 0. Okay, instead of starting like this, I'll just write the derivatives first. So f of x is equal to ln 1 plus x. F prime of x is equal to 1 by 1 plus x, and f double prime x is equal to minus 1 by 1 plus x square. And now this is where it gets interesting. F3 of x is equal to 2 by, wait, is it 2? Wait, I need to check. Okay, minus x plus 1 to the power minus 2. Yeah, it's 2. 2 by 1 plus x to the power 3. And then f4 of x is going to be minus 6 by 1 plus x to the power 4. And if you notice, this 3 gets multiplied over here, then this 4 will get multiplied over here. So well, I'll just write the first few terms so it becomes clear what I actually mean by that. So well, so ln x is equal to 0 plus x by 1 factorial, then minus x square by 2 factorial, then plus 2 x cube by plus 2x cube by 3 factorial, and minus 6 x4 by 4 factorial, and so on. And well, if you notice, this thing is 2 factorial, this thing is 3 factorial, and like I said, this is going to continue because the next term will be 4 factorial divided by 5 factorial. So 2 factorial, well, 3 factorial is basically 2 factorial into 3. 4 factorial is 3 factorial into 4. So 2 factorial cancels with 2 factorial, 3 factorial with 3 factorial. So you are left with x by 1 minus x square by 2 plus x cube by 3 minus x4 by 4, and so on. So the general term of this will be ln 1 plus x is equal to sigma and minus 1 to the power, and from k is equal to 1 to infinity, and k goes from k plus 1 minus 1 to the power k plus 1 into x to the power k divided by k. Wow, that's pretty elegant. And using this, we can approximate the initial question which had come. What is ln 2? Well, it can easily be approximated now. Now put x is equal to 1, so we get ln 2 is approximately equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 to infinity. And well, what is this value? Which is equal to 1 minus 0.5 plus 0.33 minus 0.25 plus 0.2 minus 0.16. and this thing I'll just write away to save some space. 0.04. This thing is going to be 0.21. This thing will turn up to be 0.12, and that will be 1.12 minus 0.5, which is equal to 0.72. So ln2 is approximately equal to 0.72, or e to the power 0.72 is approximately equal to 2. And that's actually pretty cool. Well, just circle this because this is an amazing series, just super useful. Anyways, that's it for the video. I hope you guys enjoyed it. Please like, share and comment on my videos, and if you have any suggestions, please comment it, or any problems which you find in my videos, please comment it. I'll try to fix it. And please subscribe to my channel and share it to those who you think might find these videos interesting.